Help in space is not coming. Not because we lack the technology or the will to save stranded astronauts, but because the universe itself refuses to cooperate with our timelines. When something goes catastrophically wrong beyond Earth's atmosphere, the people facing that emergency are already counting down their final hours, and every single system we have built to respond will arrive far too late to matter. This is not a failure of engineering or planning. This is physics drawing a line we cannot cross, and the distance between distress and rescue grows wider with every passing second. Someone spends waiting for salvation that will never arrive in time. You might think that in an age where we can communicate instantly across continents and launch rockets on demand, rescuing someone in orbit would be a matter of coordination and speed. The reality is so much worse. Every space agency on Earth operates under the same brutal constraint that has governed human spaceflight since the beginning. When you leave the planet, you are fundamentally alone. The International Space Station orbits just 400 kilometers above the surface, close enough that you can see it with your naked eye on a clear night. But that proximity is an illusion. If something goes wrong up there right now, the absolute fastest anyone could launch a rescue mission would be measured not in hours, but in weeks. And by then, everyone aboard would have already used up every breath of oxygen they had left. The first problem is one most people never consider until it is already too late. Communication with space happens at the speed of light, which sounds instantaneous until you realize that even light takes time to cross the void. A distress call from the ISS reaches mission control in less than a second. That part is fine. But the message that comes back is not a rescue team. It is a voice telling the crew to wait, to conserve resources, to hold on while engineers on the ground scramble to solve a problem they cannot touch, cannot see clearly, and cannot fix remotely. Every instruction sent up has to travel through layers of protocol and verification, because one wrong command in the vacuum of space does not get a second chance. Meanwhile, carbon dioxide levels rise inside the habitat module. Oxygen reserves tick downward. The people who need help are watching numbers on a screen that tell them exactly how many hours they have left, and those numbers are always smaller than the time it would take to reach them. But let us say, communication is perfect. Let us imagine mission control knows exactly what went wrong and exactly what needs to happen. The next obstacle is the one that ends most rescue fantasies before they begin. You cannot just launch a rocket whenever you want. Space agencies plan missions months or even years in advance because getting a vehicle from the ground into orbit requires precise alignment of fuel loads, weather windows, crew readiness, and orbital mechanics. A typical crewed launch to the ISS involves weeks of preparation, hundreds of checks, and a launch window that opens for only a few minutes each day. If you miss it, you wait 24 hours and try again. There is no emergency override that bypasses these requirements. The rocket does not care that people are dying. The fuel does not ignite faster because someone is desperate. The launch pad does not compress months of safety checks into an afternoon because the situation is dire. Every system we have is built for careful, methodical operations, and speed is the enemy of survival in rocketry. One shortcut, one skipped verification, and the rescue mission becomes another disaster on top of the first. Now imagine we somehow compress that timeline. Imagine the entire launch infrastructure pivots to emergency mode and manages to get a rescue vehicle ready in 72 hours, which would be an engineering miracle beyond anything ever attempted. The rocket lifts off. The crew aboard is trained and ready. They are coming to help. But here is where orbital mechanics steps in to destroy any remaining hope. Space is not empty air where you can just fly in a straight line towards someone in trouble. Everything up there is moving at thousands of kilometers per hour in carefully balanced trajectories. The ISS completes an orbit around Earth every 90 minutes. The rescue vehicle, even if launched perfectly, enters a different orbit with a different speed and angle. Matching orbits is not like pulling up next to a car on the highway. It is a calculated dance of velocity changes, fuel burns, and waiting for the physics to align. Depending on where the station is when the rescue launches, rendezvous could take anywhere from 6 hours to 2 days. And that is assuming everything goes flawlessly. If the station has lost attitude control and is tumbling, if its orbit is decaying, if debris has damaged the docking port, the rescue vehicle might arrive only to find that docking is impossible. The crew would be right there, separated by a few dozen meters of vacuum, watching through windows as their would-be rescuers cannot reach them. Every breath inside a spacecraft is recycled, every molecule of oxygen tracked and budgeted. The ISS carries reserves designed to keep the crew alive if resupply missions are delayed, but those reserves assume normal operations, not catastrophic failure. If the life support system stops working, if a fire consumes the carbon dioxide scrubbers, if a hull breach vents atmosphere into space, the people aboard might have hours, not days. In one scenario, they could stretch their air supply by sealing off modules and living in the smallest compartment possible, reducing their activity to near stillness, rationing every breath. But that only buys time measured against a rescue timeline that is measured in weeks. The math never works out. The oxygen runs out before the rescue arrives, every single time, no matter how fast we move. The worst part is not the distance or the time or the orbital mechanics. The worst part is that everyone involved knows this reality before they ever leave Earth. Astronauts train for emergencies, but they also train for the possibility that some emergencies have no solution. They know that if certain things go wrong, Mission Control will do everything possible to help, and it will not be enough. There is no failsafe, no backup plan that covers every disaster. The escape pods you see in science fiction do not exist. There is no way to abandon the station and glide safely back to Earth. Re-entry requires a precisely designed vehicle with heat shields, parachutes, and landing systems. The Soyuz capsules docked at the ISS are the only lifeboats available, and they hold 3 people each. If something happens that makes the entire station uninhabitable, the crew boards those capsules and comes home. But if the capsules themselves are damaged, if the docking mechanism fails, if the Soyuz cannot undock, then the crew is stranded with no way down and no way to survive until another vehicle arrives. And here is the truth that reframes everything you thought you understood about space rescue. The real enemy is not the equipment failure or the distance or even the complexity of orbital rendezvous. The real enemy is time itself, and time in space moves with a cruelty that has no human mercy. Every emergency in orbit is a countdown against physics that does not care about bravery or ingenuity or desperation. You can have the best engineers on Earth working the problem. You can have unlimited funding and political will. You can have astronauts aboard who refuse to give up. None of it changes the fact that air runs out, heat bleeds away into the void, and rescue missions move at the speed the universe allows, which is always slower than the speed at which people die. Consider what this means on a practical level. If an astronaut on a spacewalk has a suit malfunction right now, their crewmates can pull them back inside within minutes. That is the only rescue that works in space, the one that happens immediately, with people already there. Anything else is fantasy. If the entire crew is incapacitated, if everyone aboard needs help at the same time, there is no cavalry coming over the hill. The station continues its silent orbit, systems failing one by one, while the world watches and engineers calculate trajectories that will not matter. Future missions might recover the bodies, might investigate what went wrong, might implement changes to prevent the same failure from happening again. But for the people who needed help in that moment, the answer is the same as it has always been. You are on your own, and the clock is ticking faster than any rescue timeline can match. This is why every space mission is planned with the assumption that help is not coming. Redundant systems exist because there is no tech support you can call. Multiple crew members train for the same tasks, because if one person goes down, someone else has to be able to step in immediately. Supplies are rationed and monitored because running out means death, not inconvenience. The entire philosophy of human spaceflight is built around self-sufficiency, because the alternative is accepting that people will die waiting for a rescue that cannot reach them in time. And sometimes, despite all the preparation and redundancy and training, something happens that exceeds every backup plan. When that moment comes, everyone involved knows exactly how the story ends. The only honest answer to the question of space rescue is this: if you are beyond Earth's atmosphere and you need help, you will not get it in time. The distances are too vast, the physics too unforgiving, the timelines too compressed. We have sent humans to space knowing this truth, and we will continue to send them knowing it, because exploration has always required accepting risks that have no mitigation. But we should never pretend that rescue is coming. We should never sell the illusion that someone in distress can just hold on a little longer until the heroes arrive. In space, the only people who can save you are the ones already standing next to you. Everyone else is too far away, moving too slow, bound by the same merciless laws that govern every object in motion. And when the air runs out, when the systems fail, when the countdown reaches 0, the universe does not pause to give anyone a second chance. Thank you for watching. If you want to explore more about the brutal realities of space exploration, the next video covers what happens to the human body when rescue truly fails. I would be very grateful for your support, and I will see you next time.